1.1 is just a section just to get us going for the semester. So in 1.1, I'm going to work through just a few problems and shouldn't take us too long. And the first thing we want to remind ourselves is how the coordinate system works. We have an X and Y coordinate system, graph paper, then we have the X direction that's left and right, and the Y direction that's up and down. If you need to plot anything, there should be graph paper in Canvas, so you don't have to purchase graph paper. You can just go to Canvas, download the graph paper, and print out a few sheets. So remember, when we have this notation, that can mean other things. It can refer to an interval, but when it refers to a point, 2, 3 refers to the X coordinate and the Y coordinate of a particular location on the graph. So we go X and then Y. So X is left or right, Y up or down. So we always start measuring from the origin, and we go 2 in the horizontal direction, 3 in the vertical direction. So there is 2, 3. To graph -4 and -2, then starting in the middle at the origin, in the X direction, we go -4, so 1, 2, 3, 4. And in the Y direction, we go -2, so negative in the Y direction would be down. So down 1, 2. So that's to the left 4, down 2. And then 7, -2. In the X direction, we're positive, so positive is to the right. In the Y direction, we're negative. That would be down. So we're to the right 7, down 2. So we won't go into any more detail than that because most of you've been doing that part for years. So what is an ordered pair? What does an ordered pair represent? So it does represent points on a coordinate system, but it often refers to solutions of an equation. So how do we know if an ordered pair is a solution to any given equation? Well, in order for something to be a solution, when we replace our variables in an equation with particular numbers, the two sides have to be equal. They have to be of equal value. So when we substitute into an equation, into a formula, in place of something, we always want to put a parenthesis around what we're plugging in. So in place of the X, we're going to put the X value, which is 2. In place of the Y, we're going to put in the Y value, 5. And then we want to see, is this a true statement or not? If it's not a true statement, then that ordered pair is not a solution. If it is a true statement, it is. So we have to use our order of operation. Before we add, we have to multiply. You might remember, please excuse my dear Aunt Sally. There, inside the parentheses, there are no operations to do. There are no exponents, so we multiply. 2 times 2, and 3 times 5. And then 4 plus 15 is 19. And that's what we have on the other side. So yes, that ordered pair is a solution to that equation. And we could plug in other ordered pairs to see which ordered pairs make that equation work. One of the last things they ask us to do in this section is to graph an equation. So if this point 25 is a solution to this equation, then that's one of many points that we could put on our graph that works for this. There are other points that would work for this as well. If we let y be 1 and x be 8, that is another point that is a solution to that equation. If we let y be, see, 2, not 2, let's do 3. No, that's not going to work either. 3, yeah, 3. If we let y be 3, x would be 5. That's another point that is a solution to that equation. So all of those would be points on a graph that represent various solutions to that equation. Now we can graph lots of different types of equations. I believe the only ones that homework is going to ask you to graph are going to be what are referred to as linear equations, and we don't even use that terminology in the book yet, but it's where x is to the first power and y is to the first power, and they're in separate terms. And if it's a linear equation, remember, that's going to give us a line. So there are lots of points that would be solutions to this, but the instructions on this say to use the intercepts to graph this. Now, I'll go ahead and warn you, if you graph this line correctly, but don't use the y and x intercepts as your points on the grid to draw your line, then it is going to count it wrong, even though it might be actually the correct graph. So make sure that you are using specifically the intercepts in MyMathLab when you plot your graph. So what do we mean by intercepts? I'm going to pull up a grid real quickly. Intercepts are places where we touch the x and y axis. So if we have, let's say, this line, we're intersecting the x-axis here, so this is an x-intercept, and we're intersecting the y-axis here, so that's a y-intercept. And anytime we touch the x-axis, the y value is going to be 0, because if we are on this line, this horizontal line referred to as the x-axis, we have it gone up or down any, so the y is 0. Likewise, if we're at the y-intercept, then any point on this vertical axis, from the middle, we have it gone over any, so our x value is 0. So that's how we find out if we have an equation where the x-intercept is. We say, well, we know on the x-axis the y value is 0. What x causes that to happen? And if we're given an equation and asked to find the y-intercept, we know that on the y-axis, x is 0, and we find out what the y value is. So we're going to do that here. We'll say, if x is 0, what will that make y? So we're looking for the point that corresponds to x being 0. So if we replace x with 0, 2 times 0 is 0, minus 3y. 0 minus 3y, that's minus 3y. And if we divide by negative 3, y equals negative 2. So when x is 0, that corresponds to that y value. Now let's find the other intercept. So let's start with y being 0. So we're going to take our original equation, and where we have a y, we're going to change it to 0, and that's going to let us find what x value corresponds to y being 0. So 2 times x is 2x, 3 times 0 is 0, so that gives us 2x equals 6. If we divide both sides by 2, we get that x is 3. So this is the x that corresponds to that y value. So if we know that this is a line, which we haven't really gotten to that yet, but if we were to know that's a line, it only takes 2 points to determine a line. You have 2 points, you can draw a line that goes through those 2 points. So oddly enough, if we look at this graph, here is 0, negative 2. Here is 3, 0. And those are the intercepts that we just found. So if we were to plot those 2 points and draw a line through them, that's the line that we were looking for.